Adding and subtracting fractions is one of the more complicated parts about fractions that most people struggle with. Now, I think the reason most of us struggle with is because we really don't transfer what we understand about adding things together over to fractions very well. And what I mean by this, if I were to ask anybody, what are 2 cats plus 3 cats? Everybody knows, obviously, that is 5 cats, right? It's completely obvious to everybody because we know what cats are. Cats are something we can picture in our head. Those are things. Now notice when we add things together, all we do is we change how many we have, right? The things that we're adding together stay those things, right? Cats stay cats as we add them together. However, if I were to change this cats to something else, let's say like fifths and 3/5, well, fifths isn't really something that we have a good understanding of what it is, but it's still a little bit better than when we write it as like a fraction. We can still say, well, these are the same things. Here I have 2, here I have 3, so I have 5/5. All right, so if we do something like this, it kind of makes sense. But as soon as we switch over to the all math notation, people tend to get confused and make this mistake right here. You say, oh, we're just adding stuff together, so on the top we add those together, on the bottom we add those together. But that doesn't make sense because we know when we add things together, they have to stay the same. Here, these things were fifths, but we ended up with tenths. That's like adding two sets of cats together and getting dogs in the end, right? It doesn't make sense at all. So remember, with a fraction, when we have a fraction, the top or the numerator tells me how many things we have. The bottom tells me what they are, kind of like cats. Now to add things together, they have to be the same. So let's start out with a real easy example here, kind of what we just did there a second ago. If we have 2/3 plus 4/3, well, we're adding these two fractions together and they're the same things, right? These are thirds and these are thirds, which we know our answer is going to be thirds. So how many thirds do we have? Well, over here we have 2, over there we have 4, so we have 6 thirds. So now remember, once we get done adding, we just have a single fraction. We do want to see if we can reduce this, and this one actually reduces nicely just to 2. So if they're already the same thing, or the way we say that in terms of a math class, if they already have a common denominator, all we do is keep the denominator and add the numerators. So again, if we had something like 1/7 plus 3/7, well, here we're adding fractions, and they're the same things, right? These guys are sevenths, these guys are sevenths, so when we get done adding them, they still have to be sevenths. Over here I have 1, over there I have 3, so I have a total of 4 sevenths. Now, since we have a fraction here in the end, we do want to see if we can reduce this. This one won't reduce at all, so yeah, we're done. Now, this is the best case scenario when we start out with fractions that already have a common denominator. So what do we do when we don't have a common denominator? So let's take a look at another example. Let's say we have 2/3 plus 1/5. Okay, so now we're adding things together. These things over here are thirds, these things are fifths. They're not the same thing. It's kind of like saying, what's 2 cats plus 1 dog? Right? We really can't add those together because they're not the same things. Now, the difference from here, since this is kind of like real world things, we can't change cats into dogs or dogs into cats, but with numbers, we can do something like that. Now, what we're going to do is we're going to look for the least common denominator. To work. Now, all the least common denominator is, which we generally are going to abbreviate LCD, it's really just the least common multiple for all the denominators. Okay, so that's good news because we've already seen how to find the least common multiple. So if we're looking for the least common denominator for 3 and 5, we're looking for the least common multiple. I'm going to move this over here so we can see it a little better. So we got 2/3 plus 1/5. So my least common denominator or least common multiple between these two would be 15. Right, because 15 is the smallest number that is divisible by both 3 and 5. Okay, so now here's what we're going to do. Let me write this again. 2/3 and 1/5. Now our goal is to make each one of these denominators a 15. Now with a fraction, I just can't multiply the bottom by any number I want to. I have to multiply the top and the bottom by the same number. Now the reasoning here is remember, if we multiply anything by a 1, we don't change its value at all. But if we multiply by a special kind of 1 here, we can change how it looks. Watch, here's what I mean, watch. If we take this 3 and you say, okay, I want to make this 3 a 15, I got to multiply it by a 5 to get a 15. I'm going to take this first fraction, I'm going to multiply it by 5 over 5. Now the second one, I'm going to multiply this 5 by a 3 to make it a 15, so I'm going to multiply this by 3 over 3. Now, basically what we're doing here is like we're reducing backwards or unreducing. So now we have two multiplication problems. We know if we're going to multiply, we can multiply straight across. This is the wrong color. This gives me 10 15ths plus 3 15ths. Now, I know that both of these fractions can reduce, but that's because we just unreduced them kind of. Remember, our goal here is to add the fractions first. So now that they are both the same thing, we can add these together. Both of these are 15ths. How many 15ths do I have? I have 10 over here, 3 over there, so I have 13 15ths. All right, so to add fractions, we need a common denominator. And to find the common denominator, we're really looking for the least common multiple for all the fractions. So let's give ourselves just a quick note here that, you know what, I'm gonna stick it over here. Quick note to add fractions, you need a common denominator. Now notice here, and this is a little subtle thing, I didn't say you need the least common denominator because technically any denominator will work. If you don't use the least common denominator though, you always will have to reduce. Like here, we could have used 30, right? Because both 3 and 5 go into 30 and we could have made that work, we just would have had to reduce down here. Now just because you use the least common denominator doesn't mean you won't have to reduce, but it does keep the numbers a lot smaller and a lot easier to work with. Now let's try another one here. What if I did 3/4 minus 1/5? Okay, here we're still thinking about it as adding in or subtracting fractions. We need a common denominator. So here we're going to look for what is the least common denominator between a 4 and a 5. So the smallest number that's divisible by a 4 and a 5 is a 20. Now, if you can't recognize that, use one of the techniques that we saw in the past on how to find the least common multiple. So for each one of these now, let's see, we got 3/4 minus 1/5. We need to make each one of those denominators a 20. So, where's my red pen? Here we go. So to make this 4 a 20, I'm going to multiply it by 5. And to make the 5 a 20, I'm going to multiply it by 4. We multiply straight across, and what's that going to be? 15 20ths minus 4 20ths. So these things are 20ths, so I know my answers are going to be 20ths. We on top, we have 15 over here. We're taking away a 4, so we have 11 20ths. A quick check, that won't reduce anymore, so we're done. That's it. Let's try a couple more here. Let's make them a little bit messier. What if we have 3? What if we have 3/8 minus, I don't know, 1/6? Okay, so let's do this kind of in a couple stages. Do me a second, do me a favor, take a second and see if you can find the least common denominator for these fractions. All right, find it. So again, our least common denominator, which is just the least common multiple of these, we're looking for the smallest number that is divisible by both 8 and 6. In this case, it would be 24. Okay, so now that we know our least common denominator is 24, we're going to rewrite our fractions. Do me a favor, see if you can multiply both of these fractions by what it takes to make each denominator a 24. So go ahead and try that. You back? All right, so for the first one, to make an 8 of 24, I'd have to multiply it by a 3, so I'm going to multiply this by 3 over 3. To make a 6 of 24, I'm going to multiply that by 4, so I'm going to multiply the top and the bottom by 4. We multiply straight across, so this is 9 24ths minus this will be 4 24ths. These are 24ths, so that's what we're going to end up with. 9 minus 4 would be 5. Quick check, that won't reduce anymore, so that's it. That's our answer. Let's try another one. Let's get this out of here. Let's do 1/4 minus 5/6. Okay, this one I'm going to let you take all on your own. Do me a favor, find the least common denominator, add those fractions together, and see what you end up with. All right, let's see how you did. Our least common denominator, or the least common multiple for a 4 and a 6 would be 12. So I'm going to take my 1/4 minus 5/6. Now I need to multiply each one of those fractions by whatever it takes to make each denominator 12. So this is going to be, I'm going to multiply this one by 3 over 3, this one by 2 over 2. And let's see what that gives us. For our first fraction, when we multiply straight across, we're going to get 3 12ths minus 10 12ths. So we know our answer is going to be 12ths. Okay, so how many do we end up with? If we have 3 minus 10, well here we're subtracting or adding negatives. The bigger number is the negative, so we end up with -7. All right, now, in case you haven't seen this in the past, when we have negative, by the way, this won't reduce, so that's our answer. A negative with a fraction, we actually have 3 options of where to put it. We could put it on the top like this, or we could put it on the bottom. You generally don't put the negative on the bottom, but occasionally it shows up like that. Or you can just say the entire fraction is negative and write it out front. So any one of these 3 options on how you write a negative with a fraction, excuse me, generally it's the first one or the last one that you will see the most, but occasionally you do see the negative on the bottom. All right, that's about it. That's all there is to adding fractions. But let's take a look at a couple more things, just to kind of show you a few tricks that you might need to use. Get all that out of here because we're going to need some room. Let's say I gave you, what is 7 24ths plus 5 18ths. All right, so if we were to add these 2 fractions together, the first thing we'd have to do is find the least common denominator. To do that, we need to find the least common multiple between 24 and 18. Well, those are pretty big, right? So this would be pretty tricky to do. So let's do the same trick that we did when we learned how to find the least common multiple. Let's do the prime factorization of each one of these numbers. So I'm going to go over here, and again, I'm going to do this rather quick. Hopefully you're getting better at this by now. 6, that's 2 and 3. So I can see 24 is 2 times 2 times 2 times 3. We do the prime factorization of 18. We can see 18 is 2 times 3 times 3. You know, these numbers are feeling familiar. I bet you we did the same ones in the least common multiple video. All right, let's see. So our least common multiple, or least common denominator here, we know it's going to have 2's and 3's in it. Let's see, over here, the most number of 2's would be 3 of them, showing up here. This one only has 1. And the most numbers of 3's, well, this one has 1, that one has 2, so there we go. So that is our least common multiple, which is 72. Yeah, it's feeling real familiar. Okay, now this is why writing like this is going to be helpful. I'll show you here in a second. So 72. So what do we do now? 4 plus 5 over 18. Now, when our numbers get fairly large like this, it may not be an easy question to answer. What do I have to multiply 24 by to be 72? Well, here's a neat little trick. Let me get this 72 out of the way here. Since we already have the 24, if we go over to our least common multiple and cover up all the numbers that it takes to make a 24, what do we got to cover up? 3 2s and a 3, so I'm actually going to switch back over here. If we cover up 3 2s and a 3, what do we have left? Just a multiple of 3, which I'm going to have to multiply the top and the bottom of this one by 3. What do I have to multiply to get our 18 by to be 72? Well, if we come over here and cover up what it took to make the 18, which was what, a 2 and 2 3s, so this one would be better if I go to this side. If I cover up a 2 and 2 3s, I have, well, 2 times 2 or 4 left over. So that's what I'd have to multiply 18 by to make it 72. So it's a nice little trick if you have the prime factorization of the least common denominator or least common multiple. So that gives me 21 over 72 plus 20 over 72. So we have, both of these are 70 seconds. So we have 21 here, 20 there, so that gives me 41 70 seconds. And that won't reduce, so that's it. We are all done. So using our old techniques to find the least common multiple when the numbers get large can be helpful, and can also help us find out what we need to multiply each fraction by to make it have a common denominator. Now, another thing that you will generally see in all these sections is them coming back around to our order of operations, you know, the over and over and over again. Let's squeeze over here. Now remember our, hold on, multiplication, division, and add and subtract. Okay, for our order of operations, it doesn't change when the types of numbers we're working on change. The order of operations are the same no matter what. Now, it may start to look a lot scarier when we have fractions and decimals and other things involved, but it shouldn't matter. Let's just try one real quick. What if I said something like 2/3 times 1/4 plus 3/8? Okay, now the directions here would just be evaluate or simplify, one of the two. So by following our order of operations, the first thing we want to do is work inside this set of grouping symbols. Now, when fractions are involved, you may have to do a little bit of side work. Now, what I mean by side work is if we try to do everything in the problem here, it might get too messy. So since the first thing I'm going to do is this 1/4 plus 3/8, I'm just going to go over here, 3/8. So we can see our least common denominator would be 8. That's the smallest number that's divisible by 4 and 8. Let's see, let's go ahead and make our common denominator. So our 4 we'd have to multiply by 2, so I'll multiply this fraction by 2/2. This one's already an 8, so I don't have to do anything with it. So this is 2/8 plus 3/8. Those are now going to be 8. 2 and 3 gives me 5. So now I have 2/3 times 5/8. Now, technically we don't have any more grouping symbols, right? Because there's no operation inside there. So this is just multiplication. We know to multiply fractions, we multiply straight across. So we could go ahead and do that. That would give us 10/24. But remember, we can reduce first. And I see that I can reduce this 2 and the 8. 2 can go into 2 once, can go into 8 4 times. Now when we multiply straight across the top, I have 5/12. So notice your order of operations don't change. You still follow the same steps. However, when you have fractions, you may have to do a little scribble work over to the side just to kind of keep the problem a little bit neater. All right, I'm gonna give you guys one of these to try. Let's do All right, so do me a favor, hit pause, see if you can simplify this expression. All right, let's see. According to our order of operations, let me clean that up a little bit. Our order of operations, the first thing we want to do is any grouping symbols. Now, even though we have a lot of parentheses up there, there aren't any grouping symbols because there's no operations inside any of the parentheses. So let's go down. The next thing we want to try is exponents. So we do have an exponent. So that's going to be 2/3 times 2/3. So we know to multiply fractions, we multiply straight across. So if I multiply straight across, what am I going to end up? 2 times 2 would be 4. 3 times 3 is 9. All right, let's copy everything else down. 1/4, 6 ninths. All right, we don't have any more exponents, so the next thing we're going to do is multiplication or division, and we're going to do the first multiplication or division we get to. So we need to do this multiplication. Now again, we could multiply straight across, but we can reduce here a little bit first. I'm going to go and do it since this will be quick. 2 will go into both that 4 and the 6, or a 3 will go into either the 6 and the 9. Kind of up to you which way you want to do it. I saw the 4 and the 6 first, so I'm going to do that. So that gives me a 2 and a 3. So this, then we multiply straight across, what are we going to end up with? That's going to be 3/18. Now remember, before you start doing stuff, you want to simplify. This fraction can reduce some more. So let's do that before we move on. That's going to be 1/6. All right, so once we have 1/6, so now we are just adding fractions. So we're down to our last step, addition or subtraction. We do the first addition or subtraction we get to. What is our least common denominator here? Our least common denominator, the smallest number that both 9 and 6 go into, are 18. Just for room's sake, I'm going to move this up here. So we have 4/9 minus 1/6. I need to make both of those denominators an 18. Make 9 and 18, I'm going to multiply by 2/2. 6, I'm going to multiply by 3, so I'll multiply the second fraction by 3/3. So this gives me 8/18 minus 3/18. So these things are 18ths. 8 minus 3 gives me 5. So our final result would be 5/18. All right, so adding fractions, you need a common denominator to be able to add them together. That way they're the same thing. Once you have a common denominator, you add or subtract the numerators and keep the denominator. It's a skill that's never going to go away, so make sure that you know how to do it.